Hello students, Callie Daniels here. In this video we'll divide polynomials. Let's start by considering the process of adding fractions. 1/5 plus 2/5. Adding in the numerator, we can write this as 1 plus 2 all over 5, or we might say, yes, that's 3/5. And I want to just reverse this process. 3/5 then, we can write that as 1 plus 2 over 5, and I'm just reversing the process from above. And 1 plus 2 over 5 is equivalent to 1/5 plus 2/5. And this is the key to the process that we're going to use when we divide by a single-termed monomial. If we've got a sum or difference over a single term, we can separate that into its individual terms and perform division. So that's a key, and I want you to remember that step. The parts of a division problem are named as follows. Here we've got a binomial divided by a monomial and then an answer. Well, this divisor is 6x. And in the numerator, 12x squared plus 6x, we call the dividend. And the answer to a division problem is called a quotient. So you want to pay attention to that terminology as we use it as well. Now in example 1, we're going to divide by a monomial in part A, 12m to the 6th plus 18m to the 5th plus 30m to the 4th. We're going to divide that by 6m squared. So I'm going to go ahead and write this as division, 12m to the 6th plus 18m to the 5th plus 30m to the 4th. And we're going to divide that trinomial by 6m squared. Now remember our key above. Okay, if we've got several terms over a single term, we can split those up into separate quotients, if you will. So let's split this up and write it as 12m to the 6th divided by 6m squared plus 18m to the 5th divided by 6m squared plus 30m to the 4th divided by 6m squared. And now we'll perform 3 separate divisions, or you might say we're simplifying fractions by dividing common factors. Okay. Well, 12 divided by 6 is 2, and m to the 6th divided by m squared, subtracting exponents, use the quotient rule. 6 minus 2 is 4. So this first term is 2m to the 4th. Our next term, 18 divided by 6 is 3. And m to the 5th divided by m squared is m to the 3rd. 5 minus 2 is 3. Lastly, 30 divided by 6 is 5. And m to the 4th divided by m squared is m squared. Stop there. We cannot combine any of these like terms. In part B, we've got our division problem set up already, and I'm going to separate this up into its separate terms and write this as 45 x to the 4th y to the 3rd divided by negative 15x squared y plus 30 x to the 3rd y squared divided by negative 15x squared y and minus 60 x squared y divided by negative 15x squared y. And now let's just divide in each of these terms. 45 divided by negative 15 is negative 3. X to the 4th divided by x squared is x squared. And y to the 3rd divided by y is y squared. Looking at our next term, 30 divided by negative 15 is negative 2. X to the 3rd divided by x squared is x to the 1st, or x. And y squared divided by y is y to the first, or y. Last term, we've got a negative 60 divided by negative 15, which is positive 4. Our x squareds divide out and the y's divide out as well, so that last term is simply the number 4. Now just a quick, if we look real quickly at a part C, I want to do just one more and add this to our notes here. Let's say we've got 50x to the 4th minus 30x to the 3rd plus 20x. And we want to divide that by 10x to the 3rd. Separating our fractions, 50x to the 4th divided by 10x to the 3rd minus 30x to the 3rd divided by 10x to the 3rd plus 20x divided by 10x to the 3rd. In our first term, 50 divided by 10 is 5, and x to the 4th divided by x to the 3rd is x to the 1st, or x. Second term, we're going to have minus 3. Now notice that our x's divide out, don't we? Or you might think I'm using the quotient rule, and I've got x to the 3 minus 3, which is x to the 0, isn't it? But we know that x to the 0 is 1. Last term, 2. Now careful here. X to the 1 minus 3 is x to the negative 2 power, isn't it? Now let's go ahead and take one more step, and let's write our final answer as 5x minus 3, since x to the 0 is 1. And in our last term, that 2 stays in the numerator, but this negative exponent attached to the x is going to move it down to the denominator as we cross that fraction bar and change the sign of the exponent. So be careful with those and watch your exponents. These are problems where we are dividing by a single-termed monomial, and they're of the easier variety when we think about dividing polynomials. Now as we prepare to divide by a polynomial with more than one term, I want to set up a little prep work for us, okay? Let's consider long division of numbers. For example, if we divide 17 into 365. Well, 17 has 2 terms, so we'll start by dividing into 2 terms in the dividend. 17 divides into 36 2 times, and 2 times 17 is 34. At this step we subtract, and that difference is 2. Drop your 5 and complete the process again. 17 divides into 25 1 time. 1 times 17 is 17, and that difference is 8. And we can write this answer as our quotient along with remainder over divisor. That's 21 and 8/17. One more thing I'd like to look at is we check division with multiplication, and to check this division problem we would multiply our divisor times the quotient 21, and we would add that remainder. 17 times 21 is 357, plus 8 is 365, which gives the dividend, and this problem checks out just fine. All right, now let's go ahead and perform our long division with polynomials. So notice that our divisor is more than one term, therefore we're going to use long division. As we divide 2x minus 5 into 2x squared plus 5x minus 25. Now, since we've got 2 terms, we're going to divide into 2 terms and begin our quotient right here. similarly to what we did with dividing our numbers. I want you to start by asking yourself, 2x divides into 2x squared how many times? Well, you might just step out to the side and say, well, 2x divides into 2x squared x times. So we begin with x. Now we multiply back. X times 2x is 2x squared, and x times negative 5 is negative 5x. At this step, we subtract, just like we did with the numbers. Okay? So we're going to subtract 2x squared, that's a minus symbol there, and we're going to subtract negative 5x. 2x squared minus 2x squared cancels out, and that should always happen there. 5x minus a negative 5x, in other words, plus 5x is 10x. Now we repeat the process again, just like previously. Okay, there we dropped a 5, here we drop a minus 25. Now we ask ourselves, 2x divides into 10x how many times? Well, 2x divides into 10x 5 times. Multiply back. 5 times 2x is 10x. Notice the repeat of our term there. 5 times negative 5 is negative 25. And we subtract. Minus and negative becomes plus on that 25, doesn't it? Okay, our 10x's are opposites, our 25 are opposites, and there is a 0 remainder. So our quotient, or our answer to this division problem, is x plus 5. If you want to check your answer here, we would simply multiply the divisor times that quotient, and notice that we get the dividend, and I'll leave that check up to you. Let's go ahead and look at part B. Now, before we move on to part B, one thing I would like you to notice is that long division achieves the objective of keeping like terms in the same column. Okay, on the right we've got our number column. We've got a column containing x to the first power, and we've got a column containing our x squareds, our degree 2 terms. That's the same thing that long division achieves with numbers. We've got our ones column and our tens column and a hundreds column, don't we? So long division just helps us keep like numbers or like terms in the same column. Let's work part B. 2x plus 3 divided into 2x to the third plus x squared. I'm rearranging terms to write them in decreasing degree order, plus 5x plus 13. Okay, so we do want to keep like terms in the same columns, so always write your terms in decreasing degree order. 2x plus 3 divides into 2x to the third plus x squared. Okay, 2 terms into 2 terms, so we'll start our answer right here. 2x divides into 2x to the third x squared times. Multiply back. X squared times 2x is 2x to the third. X squared times 3 is 3x squared. And subtract. 2x to the third minus itself cancels, and that is always going to happen. If it doesn't, go back and fix your problem so that it does, all right? 1 minus 3 gives a negative 2x squared. And drop your next term, which is 5x. Look at your first terms. 2x divides into negative 2x squared, negative 2x times. And this is the x column, and so we know this term of our answer must have x. Multiply back. Negative 2x times 2x. All right, so that should have been negative x right there. Sorry, I could see something was wrong. Because we want to, when we multiply back, to achieve negative 2x squared, don't we? Okay, x times 2x, that's negative x times 2x is negative 2x squared. All right, just be careful on what your signs, all right? Negative x times 3 is negative 3x. And we're going to subtract. Okay, minus a negative is a plus. All right, so these cancel out, so I think we're on the right track. 5x plus 3x is 8x. Drop your 13. And last round. Okay, careful here. 2x divides into 8x 4 times. 4 times 2x is 8x. We're on the right track. 4 times 3 is 12. And we subtract. 8x minus itself is 0. 13 minus 12 is 1. So this problem has a remainder, which makes it a little bit different from part A. We're going to write this answer as quotient plus remainder over divisor, just like we did with our number division. So here comes our answer. Quotient x squared minus x plus 4 plus remainder 1 over divisor 2x plus 3. If we wanted to check, we could do that. Multiply your divisor times quotient plus remainder, and notice that you get the dividend. Let's work a couple more here and then we'll be done. All right, hang in there, you're doing great. All right, our next problem, part C. We've got x to the third minus 8 divided by x minus 2. So our divisor is x minus 2. Now, as we write our dividend, here's our x to the third term, but I'm going to put in some placeholders for some missing terms. There's no x squared term, so let's write a placeholder 0x squared. There's no x term, so let's write a placeholder called 0x. And then we've got our number only term at the end. So we want to hold those placeholders so we keep like terms in the same columns. Here we go. 2 terms divided into 2 terms. We'll begin our answer here. X divides into x to the third, x squared times. Multiply back. It's x to the third minus 2x squared. Subtract. X to the thirds cancel. 0 plus 2 is 2x squared. Drop your next term, plus 0x. Repeat. X divides into 2x squared, 2x times. Multiply back. 2x times x is 2x squared. 2x times negative 2 is minus 4x. Subtract. 2x squareds cancel. 0 plus 4 is 4. That's 4x. And drop your minus 8. Last round. X divides into 4x 4 times. Multiply back. That's 4x minus 8. And subtract. And it appears that this is going to have a 0 remainder. Our answer, x squared plus 2x plus 4. And last problem, part D. We've got some missing terms here in both our numerator and denominator, so let's put our placeholders in both places. Denominator, m squared plus 0m plus 3. Divide that into 2m to the 5th plus m to the fourth plus 6m to the third. It's important to write your problems as neatly as possible. We've got also minus 3m squared plus 0m. There's our placeholder. Let me slide this over. Minus 18. Now our divisor has 3 terms, so we're going to look at our first 3 terms in the dividend and begin our answer right here. And so we know our answer is going to begin with something m to the third power, don't we? Because this is the m to the third column. Well, let's look. M squared divides into 2m to the fifth, 2m to the third times. Multiply back. 2m to the fifth plus 0 m to the fourth plus 6 m to the third. Subtract. Our 2m to the fifth cancels. M to the fourth plus 0m to the fourth is just m to the fourth, isn't it? 6m to the third minus itself, that's a 0m to the third. I just want to leave a placeholder there so that when we drop our next term, we can simply see all 3 terms with our eyes. Repeat process. M squared divides into m to the fourth, m squared times. Multiply back. M squared times m squared is m to the fourth. M squared times 0m is 0m to the third. M squared times 3 is 3m squared. Hang in there, y'all. We're almost done. Let's subtract. Cancel. Cancel. And I'm going to go ahead and let those terms disappear on us here because so we combine our last terms, that's minus 6m squared, and we can wrap this up now by dropping our next 2 terms. So we don't need to keep that left end placeholder, okay? Come on over to your right side to find your first non-zero term. We do need to have 3 terms to divide 3 terms into, however, okay? Last round, here we go. M squared divides into negative 6m squared, negative 6 times. We got to skip a term in our quotient up here as well, didn't we? That's a number only term. Multiply back. Negative 6m squared plus 0m minus 18. Subtract. Minus the negative is plus. And minus the negative is plus. Cancel, cancel, cancel. This has a 0 remainder. Woohoo! All right. Well, that's generally as messy a division problem as you're probably ever going to see. Typically, we're going to see something more of the form of parts A or B or C. All right. But let's write this final answer and call it good. 2m to the third plus m squared minus 6 is that final quotient. All right, good luck on those and be careful with your signs when you are dividing polynomials.